Okay, we're going to talk about the volume and surface area of a sphere. To calculate volume, I just first want to talk about where the formulas might come from. The volume formula looks like volume equals 4 pi r cubed divided by 3. It was Archimedes a long time ago who figured out this formula, and this formula always confuses students because it looks kind of weird, like why is it r cubed and why is it times 4, and students sometimes ask about that. So what he figured out is if there was a cylinder drawn over the sphere, so let's say there's a cylinder and the cylinder has the same height as the sphere and the same diameter as the sphere. Basically the sphere just fits inside the cylinder. What Archimedes discovered is that the sphere is 2/3 as big. So the volume of the sphere is 2/3 that of the cylinder. So the cylinder is a little bit bigger. So if we start out first with the cylinder formula for volume is pi r squared times the height. And that is the base area times the height for the cylinder. If we also notice that this is the radius here, going from here to here on the sphere, also could go vertically. That's also the radius, and this is also the radius. So if we want to try and eliminate some of the variables, instead the height of the sphere, really, and the height of the cylinder is 2r. It's the diameter of the sphere. That is the height of the cylinder. So instead of using height in this formula for the cylinder, we're going to use 2r instead. So here we go. Now we're going to move on to the volume for the sphere. So we're saying it's 2/3 as big as the cylinder. We're still going to use pi r squared, but instead of height, because it's a sphere, we can use 2r. So if we try and simplify that, we would multiply the two 2's together and get 4 pi r. There's an r squared and another r. And because of our exponent rules, we know that that now becomes r cubed, and it's divided by 3. So that's where the formula comes from. Similarly, there's a sort of an explanation for the surface area of a sphere that's also related to a cylinder. So if I just try and get rid of that, if we're thinking about surface area, again, if this sphere just fit inside a cylinder, what Archimedes discovered is that the surface area of the sphere is that of the cylinder if we take off the top and the bottom circles and remove them. Then what we're left with is this lateral surface around this way, this lateral surface of the cylinder. And if we scrunch it all down and pack it all in and squish it all onto the sphere, the surface area of the sphere is the same as the lateral surface of the cylinder. So if we think about surface area for a cylinder, I'll try. Surface area for a cylinder was 2 pi r squared for the circles on the top and the bottom, plus 2 pi r h. And what we can also do now is realize we're going to derive our formula for the sphere from that using only the second part. The second part of the surface area of a cylinder helps us find the surface area of a sphere. So for our sphere, we're just going to use 2 pi r h. And that is the same, if we squish it all down on the sphere, that is the same as the surface area of the sphere. Why it looks a little different is, again, because if this is a radius and there's another one down here, the height of the sphere is 2 times the radius. So instead of this height, our sphere formula is 2 pi r times 2r. And when we multiply that through, we'll be able to see where the 4 comes from, because 2 times 2 is 4, pi, and then r times r is r squared. And that's where the surface area formula comes from for the sphere. So just in case you ever wanted to know, or it's ever on a test question, it's based on the formulas from the cylinder. So the only dimension that we need to know when we're trying to calculate surface area and volume of a sphere is the radius. The radius is the only dimension that we need. It's the only unknown variable in the formulas. Okay, this example talks about the diameter of a golf ball is 4.3 centimeters. So what I just said is that we need the radius for all of these formulas. So having the diameter of the golf ball isn't going to help us, except that we can use it to find the radius. So we can divide it in half and get 2.15. So that is our radius. We take the diameter and we divide it in half. Once we have the radius, we can find the surface area and the volume of the ball. Surface area formula, not too bad, just 4 pi r squared. And then we just sub in our radius. So 4 times pi, the radius we said is 2.15, and that's squared. So just make sure you're not squaring the 4 or the pi, that you're only squaring 2.15. You might want to start with that. If you do, 2.15 squared is 4.62. And then you can just multiply all your numbers together. I always leave the pi symbol in there just to remind me that I should use my pi button on my calculator, because that way I'm going to have a more accurate answer. So 4 times my pi button times 4.62 is 58.1 centimeters squared, because it's area. 4 pi r cubed divided by 3 is our formula. So after we have the formula, we're able to just go ahead and sub in our radius again, which is helpful that we've already figured out what the radius is. The radius is 2.15. That's all we need. So 4 times pi times 2.15 cubed divided by 3. And again, you might want to do this part first. That's 2.15 times 2.15 times 2.15, right? It's not times 3. You might want to calculate that first, or a lot of calculators will do it for you if you just start punching in 4 times pi times 2.15 cubed. You would get 124.89, and then we're going to divide that by 3 to get our final answer of 41.6 centimeters cubed. And it's cubed because it's a volume question. So that's kind of an example of how a teacher might try and make it a little bit more difficult for you by giving you the diameter and just hoping that you notice that you need to use the radius and cut the diameter in half. The last example here is about a baseball. Determine the radius of a baseball that has a surface area of 215 centimeters squared. I really like questions like this because it just kind of takes what might be kind of a boring question and it makes it a little bit more interesting, because you're given the surface area. It says the baseball has a surface area of 215. So a lot of students might think, well, then I don't have to do anything for this question because I already have the answer. It's 215. But what they're actually asking you for is the radius. What must the radius have been in order to get a surface area of 215 centimeters squared? So we're going to just use our area formula because it says surface area. If they had given you a volume, you would have used your volume formula, but they didn't. They gave you a surface area. So we have to start with something. Our surface area formula is 4 pi r squared. If we try and sub numbers in that we have, the only number we have is 215. And 215 is the surface area. So I know sometimes that feels weird, but we would sub the 215 in on the left because we already know what the area is. It's 215 centimeters squared. We have 4 pi r squared on the right side, and there's nothing that we can sub in for r because we don't know what it is. That's what we have to find. At this point, it becomes more of a solving equations question. I need to get r by itself. I need to figure out what r is. So I'm going to want to take 4 times pi, which is 12.6. So 215 equals 12.6 r squared. Now, a way to move the 12.6 to the left side of the equation would be to divide both sides by 12.6, which we do when we solve equations. We're trying to isolate the r. So these will cancel out on the right. R squared, 215 divided by 12.6 is 17.06. And once you know that, you're pretty close to the final answer. This is r squared, though. R squared is 17.06, not just r. So we need to be able to think of the Pythagorean theorem. And at this point, with the Pythagorean theorem, we always take the square root of both sides. So we're going to take the square root of 17.06, and we get 4.13 centimeters. And that's the radius. And that's what you were asked to find. You were asked to work backwards and find out what the radius must have been.